Okay, and the topic for the quiz, mostly chapter 2. From the beginning chapter 2 until the linear, okay, linear equations. So we are excluding the exact equation, so only until the linear equation. So of course it will be including the solution curves, the autonomous differential equation, and so on until the linear equation. I think I'm preparing around 3 or 4 questions. You can use calculator. You can bring your notes. Just one paper, A4. You can write anything on the notes. So I've prepared this from now, and I also mentioned later on Moodle. So I hope you can prepare it by yourself. Okay. So when we are having quiz, I hope you already have prepared. Okay. Because in my experience, I think from last year, there are some students not prepared well, and then they didn't prepare the notes as well. So, yeah, hope you prepared this. And then no class next week, both classes, but we have makeup class on 21.
I have mistake. I have on 21.
Oh, okay.
So can I have
No.
internet?
I think I will record as usual. Recording is okay. Maybe the WebEx. It's also WebEx. Okay. Okay, then let me continue our discussion. I think last time we have some examples on exact equation. Let me continue a little bit, and then maybe at the last 1 hour we can get more examples, especially more on the linear equation and the separable equation. But now let me conclude this exact equations. Okay, so let me add one more page here. Solve Okay, maybe you could try first. So some equations, it seems that it has a form of the mdx and dy. Okay. But before we try to make some conclusion or maybe some process, the first thing you need to do is to check, okay? So always check the equation. Oh. Okay. Okay, so the first step is check the exactness. Okay, so check the exactness. So suppose that this is m, this is n, then we are going to take partial for m with respect to y, which equal to 2e to the power of 2y, and then we are going to take product rule, right? So product rule, so let me write here first just to check. This will be cosine xy plus or minus it's xy sine xy. Okay, so it becomes plus xy sine xy minus cosine xy, and then check the partial n with respect to x. So 2e to y, and then let me write here as a product rule is cosine xy minus xy sine xy. Same, right? So we could write plus xy sine xy minus cosine xy. Same, right? So we know that both of these are equal. So we can write the next step is conclusions that a function f xy exists for the first one is m, which is the partial with respect to x, and n is partial with respect to y. We can start from the m or we start from n. Both will, I think, give the same result, but let's start from the n. Okay? Start from the n. So suppose that we have this expression. So we are writing the n is 2x e to y minus x cosine xy plus 2y. We are going to integrate with respect to dy. So integrate with respect to dy. and when we integrate with respect to y, the x we can treat x as a constant, right? So we can write f is 2x. Let me write, this is integration. And then minus x, and then integration. And then plus 2 y dy, okay? So integrate each one of them. E with power of 2, y becomes 1 over 2 e, right? So we can cancel the 2 and we can write x e to y. And then cosine xy, we integrate with respect to y, which means we're going to have 1 over x, right? So x also cancel. So we have cosine becomes sine, so negative sine xy. If you want to confirm, we can think to derive and make sure it refers back to the original one. Okay, and then y is half y squared, so y squared. Okay, and then the constant we write as a function of x. Hence, this is our solution offers for the f. The next thing is to finding this h. Right? To find the function, the h of x, we can take derivative. So we take derivative with respect to the x, so that we can get the h prime. Okay. And here is the f of x. And then take with respect to, derive with respect to x. So this will be just e, okay. And then this will result in cosine, but we need to multiply with the chain rule inside. It's y, cosine xy. And then y squared, 0, right? And then this will be plus h prime x. And this is equal to m, right? This is equal to m. So this is equal to, our m is, let me write, we're moving to the left. Our m is this, right? E and minus y, okay. So this is equal to the m, which is e minus y cosine xy. So it's perfectly fit with our expression. And then we can conclude that the h prime is 0. Okay. So h prime of x is 0. So the function itself is just a constant. Let's say it's constant c. Since it doesn't give any initial condition, so we can just write c. Okay. So the fxy then equal plus y squared plus c. Okay, that this is our function, or the solution. So, or maybe family of solutions is plus c equals 0, and then okay. think let me give you one more example of exact equation, and then we can move to exact equation for non-exact equation. So we can have a non-exact equation, but we can force them to be exact. Any question from this? If you want to try some practice to be familiar with this method, my suggestion is, since we are trying from n, you can try from n. Try from n and check whether it's confirmed it's the same or not. You can check with m, so it means that this part here will be partial with respect to x. And then we are going to integrate with respect to dx. And all the things here, we are integrating with respect to dx. And at the end here, we are getting the function of y. Okay. Just reverse, not reverse, opposite of the one that we did. Okay. You can try and you should confirm that the conclusion that both results will be similar results. Maybe the difference is just in the constant, and I think it's still okay if the difference is in constant. Okay, so let me give you one more example on this problem. So solve dy dx equal and we have y of 0 equal to, so we have initial conditions. You can also try, maybe is it going to work in linear? I think you need to deconstruct this part, right? It seems a lot of work to do, but I think we can just keep on the exact equations, which means we need to make a structure into m dx and n dy. Okay. So we need to make sure that we have m dx plus n dy equals 0. Okay, this is our goals. So we're maybe just cross multiply and then restructure the equation into this m dx plus n dy equals 0. And after that, check first the exactness. So check both partial m and n. If they are equal, it means that they are in exact equation. So we can use the exact equation method. So let's do that. So y, this is dy, and then this will be dx. Okay. So let's move to the left. So I will write cos x sine x minus xy squared dx plus y This is m and n, and we need to check the partial with respect to y for m. This will be negative 2xy, right? Check also the n. We can rewrite this as y minus x squared y, right? So I think they are equal. Okay. So they are exact. Equation is exact. So we can consider from the result here. Now we can try from n or from m. Sometimes you can decide from the m or from the n which one is more maybe simple if you are going to integrate later on. I think I will just go to n. Okay, I will choose n. So choose we choose the n. And then we take the integration with respect to dy. So let me write first dy like that. dy becomes y squared over 2, right? Y squared over 2 is also the same. So let me factor that part. So this will be y squared over 2, y minus x squared, and then plus a constant. And the constant, remember the constant, if we are taking integral as a partial, the constant will be the function of the other variable, okay, which is the x. Okay, like that. Okay, and then we take the derivative partial with respect to x. So we have dou f dou x is equal so it will be negative let me write here y squared over 2 so it will be 2x squared y over 2, so it will be x squared or 2xy squared, right? 2xy squared. So you will have negative xy squared plus h prime x. And this is equal to the m, or here is the m. M is cosine x sine x negative xy squared. Now we can see that it's fit. So the h prime is sine x cosine x. So h prime is cosine x sine x So what will be the hx? So we need to integrate, right? We need to integrate. So integrate with respect to the x. Okay, it is expected that you know how to integrate this. How?
Sine 2x.
Yeah, we can make this to sine 2x. Okay. Another way. Just using substitution, I think okay, right? Using substitution is okay. So you can take substitution and it will gives you let's say we have the cosine squared x. Okay, if we take derivative, we have 2 cosine x sine x and then negative, right? So if we take this is negative, we are getting positive, and then multiply by half, right? And by just checking trial and error, derive, integrate, and I think you can also getting easily that this is this. Or you can also take the double angle. Sine 2x is 2 sine x cos x, and half sine 2x is sine x cos x. And you can concentrate with this one here, giving you the cosine 2x, which also you can translate into the same results. Or if your calculator has integrating integral functions, you can check. But sometimes your calculator only have the definite one, so you need to put the endpoints, right? But maybe you can try. But I'm not sure. Yeah, but I think this is simple, right? You can just try each one. But I'm trying this directly because I know that if I have sine squared or cosine squared, it would getting resulting the same similar structure, right? So anyway, we can go back here to write down the formulation for the f. Okay, so f, then it's equal, and then h is minus, so minus 1/2 cosine squared x. Or we can write, let's say if this is equal to c1, and then if we multiply by 2 to make it simple, let's say it becomes c. Okay, let's say the c is 2c1. And initial condition is when x equals 0 is equal to. So we can try just input x equals 0. So this will be 4 minus 1 equals c. So c is 3. So the formula becomes y squared 1 minus x squared minus cosine squared x equal 3. Okay. It doesn't mention any explicit solution or implicit. We can just write this and write this is the implicit solution. Okay, at most, whenever you see any integrations, I think my suggestion is keep the techniques such as substitutions, integration by parts. I think if you keep these two, most of the question will be easily to be solved. Okay? So don't forget to take these two techniques, substitutions and the integration by parts. Remember, the solution for the exact equation is always the form of the functions and then equal a constant. Because the exact equation, if you remember, is m dx plus n dy equals 0. So it is expected to have a constant on the other side. Okay? So this will be the proposed solutions, and then check the initial condition, and we get the constant c equals 3. Now if you try with another, so we try from m, right? If you try from m, you need to integrate the cosine. So, wait. Let me explain from here. Okay. So we take the n, right? So if we take with m, we start from the cosine x sine x minus xy squared. So we take the integration, and we integrate first the cosine x and sine x. We integrate with respect to dx. And at this part here, we have the function of y, right? Function of y. So I believe at the end, the result will be having the same structure with the negative half cosine squared of x. Which one? This one? Here?
Why is the n in the minus?
Which one?
This code because
This- This?
in minus y.
This?
Yeah.
Oh, change.
Yeah, but you didn't go to the minus. Right?
Oh, here? I move
up to here. Yeah.
We switch I switch plus and negative. We switch from right to left. Okay, any questions? Okay, if you follow the method, it seems like long, but it has like pattern. As long as you keep on the pattern, should be okay. Should be okay. Either you choose m or n, and then you get the f. You have a function that you need to define, and then you derive one more, and then it seems like we're going forward, backward, but the idea is we need to like taking the second partial derivative, they are both equal. So fxy equal fyx. Right? That's the idea for this exact equation. Okay. Now what's happened if we have an equation that is not exact, but we would like to try forcing the exact equations? In some way, we could do that. Okay, let me explain. So let me write here. Recall that this is the structure of our exact equation. So if it's not equal, then the equation become not exact, right? But let me write here, we can multiply with, it's similar to linear equations, so we multiply with integrating factor. And let's say the integrating factor is mu xy. So it becomes, let me just copy this. Copy and then makes this a little bit. And then we have mu over here, mu over there. Okay. And now we can force this equation to be exact. So we take partial for this mu m that is equal to the one on the right side. And now both are functions, okay? Both are functions. So mu and m, mu and n, they are functions. So if we take partial derivative like this, we partially derive with respect to y and with respect to x. It means that we are going to take the product rule for both of these two sides, okay? So the first one, let me write here. So let's say this is going mu my. My means the result of the derivative plus mu y and m, okay? Just a product rule, okay? And the right one also the same. Okay. Now I will group the mu. I will group become 1. So the so we say from this part m, n, mu, and x, they are known functions of x and y. Now we need to assume, okay, assume that mu is a function of one variable. It can be x, it can be y. So we can have two options. Okay? We can assume the mu is a function of variable x or variable y. It will affect this situations, this structure. we are going to see case by case how the mu will be. Okay, so first, case 1, if mu depends only x. It means that we are going to take and solve for mu x. That is the partial with respect to x of mu equal my minus nx divided by n and multiply with mu. Because the other that has y become a constant and it becomes 0. Okay. So it means that this part is 0, right? Because we take partial for this part. Or maybe let me write. Maybe if not clear, then this is actually the mu y is 0. And the same thing if mu depends on the x, it means that the mu x will be, if mu depends on the y, mu x will be 0. So case 2. Okay, we are taking break. We can continue after break. Okay, so let me continue for this part. So case 2, if the mu depends only y. Or we could say that this will be the mu x now is 0, okay? Because we differentiate with respect to x with y, and y x become a constant, so it becomes 0. So this part becomes and then nx, what is mu y? Oh, it's become negative, so I will switch n and m. So I will have this and then mu. Okay. Okay, so from this mu, what should we put inside? Just like your linear equation, we are going to put e with power of something. Okay? Because e, as I think as we also seen so far, if we derive or integrate e, the exponent, it will get the same exponent, right? So we need to check this mu using those exponents. So mu x become e with the power of the integration of this part here. So m y minus nx over n dx. And mu y is e with the power of integration So this is integrating factor that we are going to choose. Okay, so this is the integrating factor. Mu of x or mu of y.
Sorry.
Yeah.
Which one is M, which one is mu?
Which I mean from what which part? Oh. It's mu, right? Maybe let me write more clear. Okay. And this part become M like that. And maybe this part is M. And the next question is, how do we use this mu, and which one do we should choose? The answer is sometimes we are going to have a trial and error. So first check the equation. If the equation is exact, then you can just use exact equation as usual. If it's not exact, then you need to find or choose the mu. Okay. And how to choose mu is basically based on the equations. And sometimes you need to try and see. Okay. So but let me give you some examples of how to use this. Okay, let's take example. So solve Okay, so first is check exactness. Okay. So check exactness. 2, if not exact, find the mu. 3, multiply equation with mu, and then solve the exact equation. Okay. So first is check the exactness. So m, n, right? So we take the partial of xy. This is x, and then partial of x for n. This is for x. Or we can write to make sure that this is the same as we mentioned before. This is my is x, and nx is for x. Now our options is only 2, either my minus nx over n. Okay, let me write maybe around here, or we have nx minus my over m. So this will be mu x, and this will be mu y, right? So which one we are going to choose? So it depends on our equations. So firstly, look at the m and n. Okay. The m is xy, and the n has like 2x squared plus 3y squared minus 20. It's more, I think, more complicated, and it has the x and y in terms of like a polynomial equation, right? So if we are choosing this mu x, if we choose this, then we are going to have this over with this, and we need to take this into the e, right? E with the power of these integrations. Can we integrate this easily? I think it will be very long process, right? Because we need to integrate this one, right? So I think it's best to choose the right one, because we only have nx minus my, and then over xy, or over the xy, which is 3x over xy. We can cancel x, and we can have 3 over y. I think we can integrate that easily, right? So we choose. So choose mu of y, which is e with power of. Let me move this to here. Move this a little bit to the left, and make it bigger. So this becomes e with power of 3 over y, right? Or let me write maybe 4x minus x over xy dy e with power of 3x over xy, and then this will be 3 over y dy, or we can write e with power of 3 ln y. I think we can simplify this. Taking 3 to the y here, we get e ln y cubed, or we could just write y cubed. So our mu is function of y cubed, okay? And then what's next? This y cubed, we need to bring back to our original equation, multiply all together, okay? Just like your linear equation. So it's like linear plus exact equation. So let me copy this. And then make it to the right. So this will be y cubed and y cubed. Now we can multiply and then check again. We can check again to make sure that this is correct. So this becomes xy with power of 4 plus 2x squared y cubed plus 3y power of 5. Oh, I missed out the dx. And equal 0. And then we can check again. Checking the m and n. So this will be, the only y, so it becomes 0. So this will be 4xy cubed. Okay, now we see that this is the same. Both expression, they are equal. So we can say that this equations now exact. Okay, if we are taking the m, so taking the m, let's say m, or maybe let me just write directly. So f xy is taking the integration of xy with power of 4 with respect to the x plus, or maybe just write that first. Okay. And this will be results in half x squared y power of 4, and we get g of y. And then take the partial with respect to y, So it will be 2x squared y cubed plus g prime y, which should be equal to this, right? So this equal 2x squared y cubed plus 3y power 5. Okay, let me continue on the next page. It's too much space. Okay, let me copy all this form. Okay, let me copy this and write in the new page. Okay, so it's more clear. Okay, so this is the n, right? And they are equal. So we see that this is suitable. It's fit. So we say that the g prime y is equal to 3y power of 5 negative 20 y cubed. And then we take the integration. And this will be 1 over 6, so 1 over 2. This would be 20 over 4, so 5. So solutions or proposed solution is fxy equal half x squared y power of 4 plus half y power of 6 minus 5y power of 4 equal a constant. Okay, so I think we can have some exercise now. So the exact equation finish. Okay, exact equation finish. Okay, maybe just one more announcement. Just I mentioned at the early classes, quiz 28. You can use calculator. You can use A4 notes, one paper. You can prepare your own notes. Okay. The chapter will be until linear equation. Okay. And then no class on 3rd of October and 5th October, but we are going to have a makeup class on 21. Okay, 21 of October. That's the place and time. So I will write again in the Moodle so that we are going to have this agenda. Okay, now we can move to, let's have some exercise, especially for linear equations. Okay, solve. Okay, try this one. Okay, any idea how to solve this? Some of you choosing the exact equation. That's, I think, you can try exact equation or try linear equation. Can you do with linear equation or not? Yeah, you could try. I think it can be solved by exact equation and also linear equations. So sometimes I will give you some differential equation, and you can choose which method you prefer. Some methods may be like too long, the process, and you can choose maybe which one is suitable. Let me give you some perspective how to check this. So if we assume that we can make x in terms of y, then we can make our linear equations become dx dy plus, let's say, p of y x equal g of y. This is still linear equation, but in terms of we exchange x and y, okay? We still take this as a linear. Okay? So sometimes this also works. So let's say we're going to use this part here as our method to solve. Okay? It is also true. Okay? So we make this solution as y dx dy and then equal y minus 2x, which we can simplify. It becomes dx dy equal e with power of y negative 2 over y and x. Or we could write dx dy plus 2 over y x equal e with power of y. Now if we remember the linear, we are going to take this as our p of y, right? And this is g of y. And then taking the integrating factor, we can take e with power of integration of 2 over y dy. Now we have 2 ln y, and then we have e ln y squared, then we have y squared. So we can multiply with y squared. Sometimes you will see what we did in the exact equation before, where we have the integration factor. Sometimes we see some similarity because they are actually can be taught as a similar process. Okay. because they are using the same integration factor. So we take this y squared and then using to solve this equation. So let me copy this. Let me copy. And then let's multiply with the y squared. So y squared, y squared, y squared. Okay. So we can have cancellation here. And what else do we have? I think we have all. So y squared dx dy plus 2xy equal e with both y squared. Okay. And then in linear, we need to think how the product form. Okay, so we take, now it's not the derivative of x, it's derivative of y. So maybe the one is y squared, and what is the other one is just x, right? So if we take the product rule, y squared with respect to y, x becomes dx dy. And the other part here is 2xy, right? Okay. And this equal to y squared e with both y. And then we take the integration. And we take the integration with respect to y. Okay. So we take dy dy. So dy. The left part, just take the y squared x equal. The right one, what should we do? I think just taking integration by parts. Let me do quickly here. Take this 2y, 2, 0, e, same. So plus negative. So we have y squared e minus 2ye plus 2ey and plus a constant. Okay, let's put a constant there. Sometimes you could end up until here if you want just implicit solution, but if you want to make it explicit, our solutions now becomes x equal, okay, because we make x equal function of y. Okay, we assume. So we can take x as e and then minus 2 over y and then plus 2 over y squared e and then plus c over y squared. Or if you want to make it more simplified, we can factor out e. This will be 1 minus 2 over y plus 2 over y squared and then plus c over y squared. And remember that our solutions made up from two solutions. We call this c over y squared as a transient term. And just as a note, okay, you will, I think later we'll discuss more about this. I think in the higher order differentials. So we call this is transient. Why we call this transient? Because as we take y larger, the whole thing becomes 0. Okay. So that's why we call this transient. You can think like transient is something that somehow we could ignore because it doesn't have really meaning in the system, but it's there. But the whole value, when we take it as much as the value, so when we increase the value, it's becoming more and more closer to zero. Okay? So actually, the more definite one when you see the graphs is this part here. Sometimes we call this the particular solution. Particular solution. But the one here is when we see the graph, sometimes it's not there. It's not going to be appear in the graph. Okay. Okay. So for some equations, for the linear one, usually we think that linear is dy over dx, but it can be also dx over dy. It depends our assumptions, perspectives. So sometimes we could make it happen. Okay. I think some of you try the exact equation. Do you get the final result? Which one?
The solution is y minus 2x. So it is 2. And the solution is 2 minus 1. So you want
2 minus y. Wait, let me. Yeah, you tried using exact equation. Yeah, correct. Because I'm using this A1.
So you just
I'm using just the linear. I think without yeah, still. I think to check whether it's correct or not, is checking the C. Maybe check the initial condition. Sometimes the equation is not really seems similar, but the difference is usually within the C. You can check the differences on the constant. Okay. And since I'm writing in terms of x, so maybe you will have some difference in answer. But both, like if you try the exact equations and then some of you try linear equation, as long as you are consistent, the process is correct. Both are correct. Both are correct. At least after this, one or two more methods in first differentials, then we are done, and we move to the higher order. The higher order is actually similar, but it takes much time and process. But actually, if you are looking at the examples and equations, most of the first differential equations, they are not that difficult. I mean, when you try to do the process, the only thing that maybe will be an obstacle for you is it's long. You need to write a little bit long. That's the only, I think, the only thing that maybe will make your exam difficult. It takes a long time. So that's why I'm asking you to prepare the A4 notes hopefully it will make something more easier for you. Because if I'm not giving you any context, then you need to think which method, and then your time will be running up. Right? So please prepare your notes very well. A4, you can use both sides, front and back side. Okay? And you can use calculator. You can use calculator. At least calculator will help you to confirm if it has some initial condition. It helps you to confirm directly whether your solution is correct or not. But sometimes using the notes is really helpful. It's really helpful because you have like different method at least. But for quiz, you only have at least two: separable or linear. But if you are maybe know the exact equation and you want to use it, I'm still okay with that. But mostly our questions will be, it can be solved with separable and linear. Okay. So I think I will end lecture up until here. If there's no question, is there any questions left? You have one. So the difference is in the constant.
So that's
But still okay.
still okay.
Okay, if there's no questions, then let me